In this video, we're going to talk about static methods and static variables. You can see here that I have two classes. One class usernames that has static bool TakeUsername, which takes in an std string and returns a bool. This function will claim a username on the system and return true if it was successfully claimed, that is, if it weren't already claimed. We also have a std set of std string called takenNames. This is just going to contain the list of all of the names that have already been occupied by another user on the system. Now there's one thing that we haven't seen here before, and that's the keyword static here. To understand why we use this, let's take a look at this other class, robot. Notice that I have an instance of a class wheel here. I didn't actually define wheel anywhere, so of course this won't work. But for all intents and purposes, you can pretend that I defined wheel somewhere else. Now, let's look at how we could use this. If we want to use a wheel, well, we can't use that directly. We have to use that in conjunction with the robot instance that it actually belongs to. In other words, every one of these wheels belongs to exactly one robot. Every robot has exactly one wheel. There's no wheel that belongs to the general robot. You have to actually construct an instance if you want to use it. So I could do this, and then set robot.wheel to something, or, I don't know, use robot.wheel in some way. But I couldn't do something like robot.wheel, where robot is this class, or robot : wheel. None of these actually work. Or rather, none of them are valid variables. Now let's look back at what happens when I declare these static. Static actually allows us to use these in conjunction with the class. So instead of belonging to a particular instance of the class usernames, you can actually use TakeUsername without declaring any particular instance at all. So I could do username TakeUsername Kyle, and I could take my username. In addition, this set of strings, takenNames, is also static. It exists globally in conjunction with the class usernames. So there exists one instance of this for the entire program. It doesn't, in particular, belong to some instance of usernames. It belongs to the system as a whole. So these are the declarations for TakeUsername and takenNames. Now let's look in the CPP file for the definitions, which are a little bit more tricky. We'll start with TakeUsername, the method, which has a very familiar looking definition. In fact, this is exactly like we would normally do a function, a regular instance method, but it refers to takenNames, which is a static variable, and cannot refer to any instance variables. In general, an instance is able to refer to static variables because they exist one for the whole program, so of course it's able to access that. But a static method or a static variable is not able to access a particular instance because it doesn't know which one it would be able to access. It's worth looking just very quickly at the actual implementation of this. We call a function insert on the set that we have, inserting name into that set, and returning the second return value of that returned item. The second return value in this case will be a boolean telling us whether or not insertion was successful. Alright, now let's get back into the definition of the static variable that we created. takenNames is an item of std set, and it belongs to usernames. So in general, we can write a static a static variable definition as type name, class name, : variable name. And then optionally, we can do that, or we can put equals some initializer. You learned about that in the last video, hopefully. Now, we can look at takenNames, and we can in fact assign it in this case, and we are assigning it, to a set of initial names. Here, I'm assigning Kyle and KStackowitz3 to be already taken names. That's it for the actual content and learning material of this video, but it's worth going over the test program that I have written up over here. I am going through a list of names, or a vector of names. First KStackWits 3, then ASDF, and so on. Trying a couple clever ones in there. Now, then I'm iterating over that entire list, and for each username, I'm trying to take it, and if that fails, I'm printing out unable to register user, and if it succeeds, I'm printing out registered user. Now, if I go ahead and run this, it'll give me the expected result. Now, notice that initially we are unable to register user KStackWits 3. That's because this is already claimed. It already exists in this set as it's initialized. And remember, this set is global. It exists for the entire scope of the program. So after this entire function runs, this global scoped set will have Kyle, KStackWits 3, ASDF, root, Robert drop table students, and that's about it. So, now let's look at exactly when we should really use these types of variables and these types of methods. First of all, you can notice that this is very similar to if we just had a global function and a global names. In fact, in general, static variables and static methods are basically equivalent to a global name. However, they give you a nice way of scoping things so that it is affiliated with a class that it might be logically associated with. For example, if you have a type and some operation that takes in many of that type, it might not make sense to make that operation an instance method. It might instead make sense to have it as a static method so that you could do something like type some function a, b, c, d instead of a dot some function b, c, d. Now, once again, I want to repeat this. Global variables and static variables are not very much different. And in fact, in general, we would discourage you from using them unless you really need some sort of shared global state. The reason for this is that it can make debugging very difficult. Anything is able to access this variable, so because it's global, right? It can be accessed from any context. So for some function that might use it, it might give different results depending on the state of the world. Even if all of the parameters and the object that that method was being called on, even if those were all the same, you could have different results depending on this state of the world, which can make debugging, again, very, very difficult. That said, there are many cases where you just need to do something like this, and in that case, static variables are generally preferred to global variables just because they have this nice additional element of keeping things sort of behind a namespace or behind a scope, and also, because this is private, unable to be accessed through any other methods via, other than TakeUser in this case. So, in general, you should use static methods when when the behavior of the method is logically tied to a particular class, but maybe not to a particular instance. Maybe it takes in multiple instances or it takes in no instances. And then you should use static variables only when you absolutely need to have some sort of shared state. And you should prefer those to global variables that we've learned about earlier. That's all for today's video. Thanks for watching.